Good morning. My name is Jaime Soto, and I am in the Computer Science 131 class with Professor Yuen, teaching us discrete mathematics and applied sciences. And today I am going to teach you a little bit of what I've learned so far. And one of the main things that I believe that have a very instrumental part in our society is hashing algorithms, and the way they're used in society and the way that we bring them about. And these algorithms help move our society forward. So let's get started. Hashing algorithms are functions that generate a fixed length result, the hash, or hash value, from a given input. The hash value is a summary of the original data. Now let's say you have an important file to send, and you want to ensure it'll get to the addressee or your friend or anyone you plan to send this without any changes in one piece, securely, and make sure nothing gets changed. You could use some trivial methods like sending it a bunch of times, contacting the recipient and going over it word by word, string by string to make sure everything's verified so that the file you plan to send is correct and they receive the correct amount of information. But there's a way better approach, and this is where we come into using a hashing algorithm. It creates a way to map data so it's easier to access and takes up very little space, which makes it a very efficient method. Now I'm going to show you a little map of kind of how a hashing algorithm works, a very simple one. And basically it starts with you entering input data. The hashing algorithm uses bits and bytes to create a hash, or the output. The hash is important because if you and your recipient own the same hash, that makes the file verified and saying that it is correct and you have the same piece of information. The hashing, and a little bit of how it works, is hashing algorithm is a cryptographic hash function. It is a mathematical algorithm that maps data of arbitrary size to a hash of a fixed size. Size that normally never changes and allows us to keep information the same. The hash function algorithm is designed to be a one-way function and feasible to invert. Basically saying that no matter what you give it, it will always bring back the same function. And this allows the retriever to use information in the form of a hash from the data to relative ease. So you're able to basically find information relatively easy when it comes to your users or even to your recipients. Now, I found this little map on the internet that makes it really easy to understand. Now, user 1 sends a file to user 2 alongside the checksum. The checksum is what is used to verify the file. Now, the file and the hash are sent to the user. And now that the user has the file, they themselves use the same hashing algorithm. Now, the user 1 can't tell user 2 exactly what is on it, especially if the time is of use. So the user 2 has to use the algorithm to figure out if they are both the same. Now the best way to use it is using the hashes. Now if you compare both hashes and they're the same, the file is the same, and that makes the user, the recipient, aware that the file they received, it is the correct file and has not been corrupted in any sort of way. However, with technology comes a little bit of caveats. Like in recent years, several hashing algorithms have been compromised. And as useful as this algorithm is, it does have its negatives, such as not being the most secure system out there. For a very long time, the hashing algorithm MD5 was one of the more used to securely pass information, but recently that has changed, as this method has been reversed, and even a simple Google search can use your data can be used to find your data. Now MD5 maybe 20 like 10 15 years ago was the way to go, and we thought that there was no way it can be found, it can be reversed, but with technology comes ways to work around it. And now MD5 is considered corrupted, considered old, and like I said, a simple Google search can basically find all the information you need. The use of hashing is very popular, but to make it sure it's completely secure, one way would be to keep up the updates. So the technology you use keeps in touch with the algorithms that may have become unsafe. Now, where we use these hash algorithms has been seen in many ways around the world. And one of the more important ones is privacy. The use of hash is very useful in privacy. Many industries like the police need security that a hash gives us to store and protect fingerprinting and records of former criminals or just records overall. Now, many computer virus software applications use hash to find duplicate data files and corrupted files that do not match the original file. And even more importantly, websites such as Amazon and basically any website you might need to use a password is used, but not exactly the way you think. Websites' use of hash is not to store their users' passwords, but to be able to match the passcode they entered with the passcode that the websites have registered for them. So this is basically saying that they might not exactly have your password in their systems, but they have the ability to match yours with theirs to be able to unlock the information that you have with this company or website or Facebook or anything. There are some issues that come with it, such as how sensitive it is in casing. And one of the main problems that comes with this is the avalanche effect. When using hash algorithms such as in blockchains and cryptography, the sensitivity of casing and even the slightest change in a variable can have many undesirable results. The change in one singular detail in the input can flip half the code to a different product. This makes it imperative that we get the data correct from the start, the data we input into the algorithm, because as much as you might be disappointed of the product that comes out, you may have just put the wrong input. So it's very much important that the user is aware of the information they're putting in as much as the algorithm is doing its part. Now, obviously the most popular way of hashing, the hashing algorithm, is in cryptocurrency. Now, hash is a common term when discussing blockchain technology. Hashing refers to the transformation and generation of input data of any length into a string of a fixed size, which is performed by a specific algorithm, which is basically what we just spoke about for the last 8 minutes. But in particular, the Bitcoin hash algorithm that is used now is SHA-256. That is basically kind of the replacement for MD5, which we spoke about recently, that has been very much outdated. This is a one-way cryptographic function, as the original data cannot be retrieved via decryption. The only way you can use this data is by using this algorithm. The SHA-256 is actually considered the secure hashing algorithm, and like I said, it's still used over MDA. The use of hash is important in blockchains as it does not allow multiple uses of the same code. And when it comes to blockchains and bitcoins and all that, the most important thing is not the use of duplicate data, because Bitcoin itself is a singular piece of code, and there's only a certain amount of code that is lent out to the world, and there's only a certain amount of numbers that the blockchain can help. Now, why does it all matter? Well, the use of hashing algorithms seems like a bit overkill. With being able to go out about it the old-fashioned way of calling someone and just going over information bit by bit to secure the same information. Unfortunately, it is in a fast-paced world we live in. The time to verify information is very much a nuisance when dealing with thousands of users. In this time and age of information, nothing is more important than keeping your private data safe from corruption and the retrieval of unknown figures. And that was my presentation on hashing algorithms. And I just want to thank you for listening and hope you have a great day. And make sure to look into how we can keep up to date in this wonderful fast paced world of hashing blockchains and bitcoins.